we're going to do inverse functions, and I chose this one because it's pretty simple. So if you guys would come up and carefully put them in, pull out the tray so that you stick them from the top and go from the side where they get scratched. Yep, we're going to write that. Okay. Essentially, actually, let's think back to when you first started solving equations. What's the inverse operation of addition? Subtraction. And subtraction's inverse is addition. So we like go back and forth, right? What's the inverse operation of division? Multiplication. Multiplication's inverse is division. What's the inverse operation of a square root? Squaring. Okay. If X's and Y's switch places. So on number 1 and 2, we have, you see how there's like curly braces? That's called a set. And inside the curly braces are a bunch of points listed. So if I ask you, and this is called a relation, if I ask you about the inverse relation, all you have to do is switch the X and Y. If the original point was 1, negative 3, what's the inverse relation? The sign stays with the number, so it stays with the 3. That's a good question. The sign stays with the number. Okay. Our original is negative 2, 3. What's the inverse? Okay, everyone catching this? Joshua, the original is 5, 1. What's the inverse? Yeah, finish off the set, close up the set. Okay, can you do, at the end, can you do number 2? That's what you do for word pairs in relation. So number 1 and 2 are the same types of problems. Okay. Now, 3 through, I think it's 17, is a different set. It's not a set of word pairs, it's an equation. Find the inverse equation. But an equation is graphable, which has points, right? Like this. Y equals 3x plus 2. What type of graph does that look like? Linear. It's a line. Each point on the line has an x and y, and so those x's and y's are the flip-flop places. And we can find this algebraic. Okay. The steps. Those wires, I think I did all of those. Okay. X. Well, I'm just sure I did all Y's, so I should probably make some of those up for X's. So we're in next on the first step. That is to do what we just did up above. What do we do with the X's and Y's up above? Switch them. by y. And then to know that if you keep in I want you to do this, I want you to do it in terms of alphabets. We know it's the inverse of add an exponent of -1. So if it's in the form of a y, it'd be y to the -1. The f function notation would be x to the -1 of x. So, those are all the steps. So our steps number 3, and they're pretty straightforward. Number 3. First step, instead of with y, I'm going to rewrite it and replace the y with what? F of x. F of x equals 3x plus 2. Now what do I do? Switch. That doesn't mean that everything changed the location. It just means rewrite it with the other one. So instead of f of x, I'm going to write what in its place? I'm going to write x. Instead of 3x, it's not going to be called 3x anymore, it's going to be called, yeah, I think I'm going to go back to after that notation. So, sorry. Switch out of x and y, put y equals, then you want that for that, which is going to confuse you. So we replace the y with x. Now instead of saying 3x plus 2, it's going to be 3y plus 2. So the 3 and the 2 stay in the same spot, just the x and the y's are written as the other form. And now we're going to solve for y. But y used to be on the left, now it's on the right-hand side. How do we get y by itself? Subtract 2. So we have x minus 2 equals 3y. Okay? So that's how do we get y by itself now? So how do you divide everything by 3, right? So we need to divide the whole thing by 3. So we have y equals to make sure we know that this is an inverse. So it's not just y anymore. This should be y to the -1. Y to the -1. So if you ever see an x to the -1, it means the same thing. It means it's an inverse function. Okay, let's try, how about number 7, yeah? After the -1 of x, yeah. Okay, let's try number 7. There's a fraction involved. But I have one. We're not going to change that next. That just is going to make it messy, so let's not do that. So the second step we wrote is switch x and y. So instead of the y, I write a and x. So 2/3 will stay in the same spot. After the 2/3 will split the x, I write a y minus 5. So the 2/3 of minus 5 stay in the same spot. Sometimes people try to move those, so don't move them. Okay, step 3, solve for y. Okay, so we need y by itself. Okay, Christian, how does I get y by itself? Add 5, good, for both sides. Add 5 to both sides. So we have x plus 5 equals 2/3 y. Any questions up to this point? Okay, now we have to get y by itself. There are two ways we can do this. One way, in my opinion, looks a little more complicated than the other way. This is 2/3 times y, so then we divide by 2/3. That's what it's dividing by fractions. No. There's the second option. Instead of using division, what's another option we can do to get y by itself? Times by the inverse. Let's put the fraction called, so give an r. Reciprocal. Reciprocal. Technically, the fraction is division, so the inverse of division is multiplication. So we're still doing an inverse. As long as my 3 is on top, the 3 will cancel. As long as my 2 is on bottom, the 2 will cancel. That's why we use reciprocal. To everything. So I have plus 3 times 5. 15. Doesn't divide nicely. If it was like 16 halves, I would change that to an 8. But it doesn't divide nicely. This is not the original function. So that's what it is. Right. -1. The -1 shows me it's an inverse. Okay, I think on the next page we have some more complicated ones with square roots. Okay, let's try number. Okay, we're not going to change it to f of x, so that second step we wrote. What's the second step, Lena? That we wrote on our paper, but switch what? Switch x and y. So instead of the x underneath the square root, I'm going to write a y. Okay, now we're going to solve for y. We have to get y by itself. Think of a birthday present. You have to work on the outside first before you can get to what's inside. That's y is trapped inside of a box that's been wrapped in. How do you get rid of the box? It is the square root. It's the inverse of the square root. Squaring. The squaring, the squaring cancels out the square root. That comes also square the other side. So I have x squared equals the square root's gone, and it leaves just underneath in the radicand position, the y minus 2. Okay, come on, how can you just get y by itself? Add 2 to both sides. So x squared plus 2 equals y. Actually, I think this is a typo. This should be all y is greater than equal. That's fine. I thought it was all x was greater than equal. Okay, but instead of the y, we can start with y. What does it have to be? -1. Now remember, we switched x's and y's. So this right here is called a restricted Run-Length domain. The y goes up and down. It's spread horizontally. Restricted range. Now that should switch as well. So instead of y is greater than or equal, y has to be replaced with x is greater than or equal to 0. So it also needs to switch the restricted domain. Okay, let's say you do it algebraically. The last section is even easier than Even though that's not as hard as it gets. Any questions on the algebra part? Okay, so let's start. There's only 4 of them. So on the same graph, it says graph the inverse, and I changed it. That's actually not to do. I think it says 18. Okay. It says graph the inverse relation. You can see there are some points. The name of that point. Okay. Clinton. What's the name of it? What's the name of that point? That point. 0. Okay, I'm going back. -1. Oops. X is 1, and left and down is 0. Okay, graphing the inverse. Okay, write something. I'll give you your pencil. Okay, the inverse. So, X and Y all switch places. Okay, so standing with the inverse point of -2, 3. Okay, and our original point of -1, 0. Emily was the inverse point. 0. Okay, what about 0, -1? What's its inverse? -1, 0. Okay, Jackson, if we have 1, 0, what's the inverse? 0, 1. Okay, Sabrina, what about 2, 3? What's the inverse? 3, 2. Now, on the same graph, we're going to plot this point and see how the graph looks. 3. Switch X, Y, our problem no longer goes up. Sideways. Okay. Also, it's no longer a function. Remember the vertical line test? Translation that fails. No longer a function because it fails the vertical line test. Okay, so that's how you do it graphically. Make a list of all the points you can see, and then switch them, and graph it on the same graph given. Does that make sense? Homework. So bring what you have. We've done a handful already. By Friday, those of you who didn't do your homework on that itself, that is your final deadline, and it will never be open again. It was a Friday. You need to come in here after school and borrow a Chromebook and stay in the classroom, and I can help you after school to help you get you a math Excel done. Yeah. Thursday. Thursday is probably a day I can't be here because I think I have my talking with students on Thursday after school. I apologize. We have a new room out of us today. There's a district training computer Wednesday. They said either today or Thursday, and they never gave a date. Okay. Well, Tuesday, Wednesday, or Friday. Do those, okay? Right, and if calculator, just put the lid on and come back to the front and put it in order, please. We also have Mr. Cook tutoring in the morning, Tuesday morning, Wednesday morning, because right across the hall. The train at 8 and 9. Calculator's up, please. Hey, Jason. That's not wrong now. It's come on top. It'll go to England 14. Should I make a new row? Right there. We have 7. Oh, wow, there's some nice fingers. 19. 19. 26. So Mr. Calculator, that was my door. And if you're calculator, you can't leave. The calculator needs to be brought up. Where's number 2? Please come on up by the door. Where's number 2? Who's on the calculator?